We will be presenting on time series analysis with long-term forecasting. Data analytics is composed of three levels. The first level, descriptive analytics, is the interpretation of data to better understand changes that have happened in a business. Popular examples are data queries, reports, descriptive statistics, data visualizations, data mining techniques, and what-if spreadsheet models. Descriptive analytics simply describes the past using a range of data to draw new comparisons. The second level of data analytics is predictive analytics. It consists of techniques that use models constructed from past data to predict the probability of the future or ascertain the impact of one variable on another. Survey data and past purchase history behavior may be used to help predict the market share of a new product. In this course, we have forecasted using simple regression, multiple regression, and exponential smoothing techniques. Our topic of long-term forecasting falls under predictive analytics. The third level of analytics is prescriptive analytics. It indicates a best course of action to take for a given situation using optimization models, simulation optimization, and decision analysis. It's referred to as the final frontier of analytic capabilities, and it uses the application of mathematical and computational sciences and suggests decision options to take advantage of the results of descriptive and predictive analytics.
Data analytics plays a vital role in helping many businesses succeed. It helps businesses harness their data and use it to identify new opportunities and better understand the market. It helps predict customer trends and behaviors while increasing business productivity. An analyst can analyze, interpret, and deliver data to a manager in an understandable way, which in turn could lead to things such as better decision-making, new products, or cost reduction. For this time series analysis project, we focused on predicting the amount of packages sold for a vacation rental company using a file that provides us with 10 years of monthly sales data for the company. This analysis will forecast sales, which can be useful to predict revenue and profits, the amount of products needed for the rentals, and allow insight to determine how many employees need to be scheduled or hired. There are several different options for long-term forecasting, the first of which being simple linear regression. This would be used when you have one independent variable. The second is multiple linear regression, which is used when you have multiple independent variables. Lastly, double exponential smoothing can be used when a trend is present, or you can use triple exponential smoothing when a trend and seasonality are present.
When first looking at our vacation package data, we must assess the data for seasonal effects, cyclical effects, and trends. To make it easier to check for these, we will create a graphical representation of our data. So first, we must highlight the column with our package sold data, then go to Insert and select Line Chart. Now looking at our graph, it is clear that there is an overall upward trend in seasonality, with packages sold spiking in the summer months. Since it has both a trend and seasonality, we have two options to choose from to predict future vacation package sales: triple exponential smoothing and multiple linear regression. For this case, we will do multiple linear regression because it has a lower mean squared error. Since the months are all categorical variables right now, we need to make them quantifiable. We can do this by creating dummy variables. As you can see from the visual, we did this by entering a 1 for the period corresponding with the matching month. Now that we've set up our dummy variables, we can do the regression. To do this, we'll use the data analysis software in Excel. We go to Data Analysis and select Regression. The Y range is going to be our packages sold. And then for the X range, you're going to select the year and each of the months that we have created to be our dummy variables. Now we can see from our regression that about 86% of the variance in packages sold can be explained by our variables. We also find that in the p-value that there are some variables that are not significant because they are larger than value of 0.05. However, for right now, we're going to leave them in. Next, to calculate the predicted sold, we're going to take our coefficients and then plug them in to our equation. As you can see here from the formula bar, how the predicted sold is calculated by taking each of the coefficients and then multiplying by its corresponding variable. Now to find the MSE, we're going to first find the error, the difference between our packages sold minus the predicted. And you do that for each. Then you're going to square that and do that for the whole column. And to find the MSE, you just take the average of this column of your error squared. We find that the MSE for all the variables is about 8 million. Now let's look at a predictive model that excludes the months that we found to be insignificant. Those months were January, November, and December. Again, you would run a regression with the packages sold being your Y input, and then the year and the months with the dummy variables as your X input. And we find that the coefficients for these variables to be as such, and we use those to calculate the predicted sold. And just like earlier, to calculate the error, you take the actual minus the predicted. And then you square that error. And to get the mean squared error, just like before, you're going to take the average of this column. And with that, you find that the mean squared error with our predictive model that excluded the insignificant months was actually higher than the MSE of the model with all the months included. Since the MSE was lower for the predictive model with all the months, that is the model that we would use. Next, we will run a model which includes the vacation package price for each of the months. When we include the price, this makes it an econometric model. And just like before, we're going to run another regression. However, this time, for the input X range, we're going to include the variable price. As you can see from this regression, we find that 92% of the variance can be explained by these variables, which now include the price. We now take the coefficients that we find for these variables and bring them over to calculate the predicted value. We've already brought over the coefficients and we've already calculated the error. When we look at the mean squared error, we find that it is much, much lower, which makes it a much better model. Now that we've created a few models, let's try to predict the value of how many packages will be sold the following June. Since we don't have what the prices will be in the following year, let's use one of our other models. Now let's set up what the following year will be. And all you have to do is click here and drag down. Now, for the month of June in the next year, we find that the predictive value of the amount of packages sold will be 77,066.